In this video, we are looking at this problem on page 17 of the chapter 3, section 4 slides. Consider the problem posed in our first example. This was maximizing subject to maximizing p equals 2x plus 1.5y, subject to 3x plus 4y less than or equal to 1,000, 6x plus 3y less than or equal to 1,200, x less than or equal to 180, and x and y both greater than or equal to 0. We first find the range of values that resource 1, constraint on the right-hand side of constraint 1, can assume. Got our same graph here. So we want to suppose that the right-hand side of constraint 1 is replaced with 1,000 plus h, where h is a real number. And then the new optimal solution occurs at point D prime. I don't have that line in there, but or point D prime, but we will look at this back in our notebook. To find the coordinates of D prime, we solve the equation 3x plus 4y equals 1,000 plus h, 6x plus 3y equals 1,200. So we multiply our first equation by 2, which gives us 6x plus 8y equals 2,000 plus 2h, and we've got 6x plus 3y equals 1,200. And we subtract. So we're left with 5y equals 800 plus 2h. Or y equals 2/5 times 400 plus h. We substitute this value of y into the second equation in the system, which gives us x plus 6/5. I get the wrong equation here. 6/5 times 400 plus h equals 1,200. Divide everything by 6 to get 6x there. X plus 1/5 times 400 plus h equals 200. So x equals 1/5 times 600 minus h. Now, we know y is non-negative. That comes from our original set of equations, or inequalities. And the non-negativity of x, this implies that h is greater than or equal to negative 400. And the non-negativity of x implies that h is less than or equal to 600, but also x is less than or equal to 180, So that means that 1/5 times 600 minus h is less than or equal to 180. And that comes out to, when we solve this for h is greater than or equal to -300. So this tells us that -300 is less than or equal to h is less than or equal to 600. So the amount of resource 1 must lie between 1,000 minus 300, or 700. And 1,000 plus 1,600, or 600, which is 1,600. There is the answer to this first part of the question. The second part, we set h equal to 1 in part A. So we get x equals 1/5 times 600 minus 1, which is 599 over 5. And y equals 2/5 times 400 plus 1, which is 802 over 5. Then the profit realized at this level of production, P equals 2x plus 3/2 y, gives us 2 times 599 over 5 plus 3/2 times 802 over 5 is 2,401 over 5, or 480.2. Since the original optimal profit for this problem was $480, we can see that our shadow price is right there. It is 20 cents. All right, that's it for this problem. If you have any questions, let me know.